Let's discuss today in this video how to design the earth mat, whether it is uh, whether it is a, power plant network or any other utilities, power generation or any substation. We need to do this calculation, ground grid design, and this video will cover the earth mat sizing, how to do that in Excel spreadsheet based on the IEEE 80 IEEE 80 guidelines. We will discuss. Let's say this is 70 meter 70 meter wide, and length is 75 meter. So for this area, let's say this is powerhouse, let's say this is a substation or maybe a utility system. So how to design that as per IEEE 80 standard? And to do that, we need to keep in mind that the allowable ground resistance, RG, grid resistance, that should be below acceptable value of 1 ohm. So this will be our objective, and how to do the calculation using the manual spreadsheet and with the help of the equation of IEEE 80, we will see in this video. So let's start from the beginning. So first of all, this is as per IEEE 80 guidelines, and what are the input parameters we need to do before the calculation. Let's say this the these are the inputs. Let's say this is soil resistivity. So soil resistivity, we need to carry out the soil resistivity test uh, at site, so that we can get the data for this soil resistivity. And also the soil resistivity depends on the profile of the soil where the unit or the facility electrical facilities are located. Let's say it is a substation, or it's a power plant, or it's an utility area. Total area includes, for this calculation, we need to consider the total area. What is the area of that? That means the length and width. Okay, so there are some parameters based on IEEE 80 requirement. I will show you. And first of all, this is the electrical soil resistivity test report. So we need to measure with the help of some standard measurement practices. So it may be through a third-party agency or anybody who can do this work, who are expert in this field. So the site data, the soil resistivity profile that is required. So here, let us assume that the fault current is considered as 31.5 kiloamps for the 11 kV system. In this design, we have considered 11 kV system where the rated short circuit fault current is 31.5 kiloamps. Okay, so these are the input parameters. Symmetrical short circuit current, which is 31.5 kiloamps. Fault current, this is the fault current diversity factor. Shock duration for the body current, whether it is 50 kg or 70 kg body weight, depending on that. That's the shock duration. Let's say it is assumed as 0.5 second. So where to get this data? It may be 0.1 second also. So if you check the IEEE 80, I will show you IEEE 80 how to find out that shock duration. It is there in the IEEE 80 guidelines. Okay, so TS. This is the TS. TS is the shock duration margin ranging from 0.03 second to 3 second. Yeah, so this is the equation. IB equals to K by square root of TS. The duration for which a 50 Hz or 60 Hz current can be tolerated by most of the people actually depends on the body weight. Let's say this equation is applicable for 50 kg body weight. What is the equation? IB equals to 0.116 by square root of TS, and here 116 milliampere for TS equals to 1 second, and 367 milliamps for TS equals to 0.1 second. So because this is limited within this range 0.03 to 3.0 seconds within this. So this is the shock duration. Here we have considered 0.5 second. Surface layer that may be a gravel, uh, let's say for a substation, generally that is gravel. After the finished ground level FGL, that gravel is there. So the gravel resistivity is 3000 ohm meter. Okay, and soil resistivity, this data will be available from the site measurement, as I have already discussed. So this is 36.47. This data is coming from the site test report, soil resistivity test report in ohm meter. Depth of burial of earth material, let's say it is 1 meter. 1 meter is considered uh, below the finished ground level. 1 meter depth. The earth material, that means whether it is earth rod or flat material, ms that flat material that will be laid 1 meter below the FGL. Number of electrodes, so that will be calculated. Length of ground rod, that will be calculated also. Okay, now the maximum length Lx and Ly, that means this is the length of the area, whether it is powerhouse, power plant area, or the substation area. Let's say this is 75 meter by 70 meter shape. Average grid spacing is considered 5 meter. That means 5 meter by 5 meter grid. What is this? Let's show. Yeah, this is 5 meter by 5 meter, 5 meter by 5 meter mesh, and total is 70 meter wide and 75 meter length. Okay, so this is done. Now 40 ms rod, that means mild steel rod, is considered. This is the conductor type. Okay, minimum conductor cross sectional area required, so this will be calculated based on the IEEE equation I will show you. And thermal coefficient, also these are the material properties. Time duration for sizing earth mat conductor is 1 second, and conductor earth mat short circuit rating is 31.5 kiloamps. Now, as per the equation number 40 of IEEE 80, the minimum conductor size required, that is calculated based on this equation. So where is this equation? If I show you IEEE 80, so this is equation number 37. Okay, so let's go to equation 40. Yeah, this is the equation 40. So here A means conductor cross section in square mm, so that will be calculated based on this formula. The same is written here in this formula. Okay, now These are the values we have considered. Equivalent dia of MS rod selected, which is 40 mm, 40 millimeter. This is a total cross sectional area of underground earth mat. Now the reduction factor CS, these are also as per the equation uh, which is mentioned in IEEE 80. This is the CS, which is the reduction factor. And soil resistivity, this is already measured at site, 36.47 ohm meter. Okay, surface gravel layer resistivity, which is 3000 ohm meter. This is the shock duration, 0.5 meter, 0.5 second. And this is as per the IEEE 80 equation. E touch, the tolerable touch voltage, and this is tolerable step voltage. So these are these are two equations obtained from the IEEE 80, equation number 32 and 29. So what is touch potential and what is step potential? If you are not aware of this, you can go through the IEEE 80. So in the IEEE 80, this definition is provided. Let me show you. What is this? Is the GPR, ground potential rise. So I will show you what is step and touch potential. Yeah, this is the step voltage, the difference in surface potential experienced by a person bridging a distance of 1 meter with the feet without contacting any grounded object. So that means one step 1 meter apart. So that means this is step voltage. And what is touch voltage? Touch potential, this is touch potential. The potential difference between the ground potential rise GPR and the surface potential at the point when a person is standing while at the same time having a hand in contact with a grounded structure. This is touch potential. So whenever we are going to design the earth mat, we need to check the touch potential and step potential. So using this equation 29 and 32 of IEEE 80, we need to calculate these two. Now maximum metal to metal touch voltage, this is calculated using the formula. And GPR, this is ground potential rise, which is IG, grid current multiplied by grid resistance, IG into RG, which is 5.168 volt. Now coming to the grid configuration. Grid configuration, that is the 1 meter depth. This is soil resistivity. This is L length 75 meter. This is width, distance in y direction, which is 70 meter. That means 75 meter by 70 meter. Area we are considering an average grid spacing is 5 meter, 5 meter by 5 meter mesh. And number of conductors, we have considered 16 numbers. Okay, 15 number of conductors along the width side. This is towards the length, that means 75 meter length, 16 numbers. And towards this 70 meter y direction length or the width, total 15 numbers we have considered. And based on this is the LC and NR. Number of electrode is 20, considered 3 meter length electrode. And LR is calculated, and here this LT equals to LC plus NR into LR. Total length of conductors is calculated. This is also as per the IEEE 80. And total area of earth mat is 5250 square mm. From here we can see the square root of A, which is 72.46 square meter. So where from this equation is coming, LT equals to LC plus NR into LR, it is also specified in the IEEE 80. If you go through the IEEE 80, then you can find out that equation as well. Let me check. Yeah, CS value, this was the CS value, surface layer deteriorating factors. Yeah, this is step and touch potential. And this is the algorithm how to design that, how to design earth grid. This is the algorithm, and this algorithm flowchart is written here. This is the mesh voltage. Yeah, this is the algorithm step by step. Yeah, so this is the thing what I was talking about. Lm equals to Lc plus Lr, where Lr is the total length of all ground rods in millimeter. So here a Lm is calculated in this way, and finally it is coming Ls equals to 0.75 Lc plus 0.85 Lr. This one in terms of equation it is like this. And here if you put all the values here, so you can get the ultimate result. I will show you. Yeah, this is the value of Lm, Ls, and R, and this is Es, which is the step potential. This is the attainable step potential, and this is attainable touch potential. Em equals to 380. 366 is the step potential, and Em is the touch potential. And here how to check the safety. So this touch voltage, which is 380.54, and from the calculation it is 675.95. 6, that means D170. If we go there, D170, yeah, this one. So this is the calculated touch potential for a 50 kg body weight, 675.95, and here it is. Yeah, so this calculated value is 380 only. So here the touch voltage is less than the calculated or the tolerable touch voltage. So this design is safe. Now coming to the step potential checking, here it is 366 volt, whereas the tolerable calculated value is 2211. So where from this is coming? This is coming from D173. Let's check that one. D173, that means this one. This is the step potential. So 2211 volt for a 50 kg body weight, E step 50, from the IEEE equation number 29. This is calculated, which is 2211 volt, whereas the uh, attainable step voltage, considering all the number of vertical or horizontal conductors, considering number of that electrodes, 3 meter long electrodes, which we consider the 20 numbers. Nr is 20 numbers electrode. So considering all this, and this is the electrode length, which is 3 meter. So considering all these electrode configuration, that is the and also the 5 meter grid span, that means 5 meter by 5 meter mesh. 16 numbers, 16 numbers, that number of conductors along the length, and 15 numbers along y-axis. So considering all these parameters, we have attained this much of touch potential and step potential, which is well below the tolerable or the calculated touch and step potential. So that means, as a conclusion, we can say that this 40 millimeter, this 40 mm dia MS rod or mild steel rod that is to be laid along with the 3-meter long 40 mm dia MS rod with the numbers whatever specified above to restrict the touch and step potential. And this is the area what I already explained. And as per the equation number 52 of IEEE, the RG or the grid resistance, ground grid resistance, that is calculated by this, which is coming 0.234 ohm, 0.234 ohm, which is well below the allowable value of 1 ohm. Hence the design is okay. So this design is verified and validated. So likewise, we can check considering the number of conductor horizontal or vertical conductors, number of by changing the that electrode configuration, number of electrodes we can change, and we can get different values of Rg. So this is the final thing we need to check, the value of Rg, ground grid resistance, that should be below the allowable limit of 1 ohm. So finally, these are the things: the touch and step potential, and finally that ground grid resistance, which should be below 1 ohm. And using the ETAP simulation software, you can do the same thing what I have just now explained in this Excel spreadsheet. The same thing can be simulated there, considering and changing the parameters, changing the input parameters, changing the soil resistivity profile, changing the number of ground grids, or the size or the number of electrodes, and that optimization can be done. You can check out that video. So up to this, thanks for watching this video, and if you have any query, you can put your comments in the comment box. I will come back to you.